Before we can talk about adding and subtracting rational expressions with different denominators, we have to first talk about how to find the least common denominator. So, looking at these two examples here, we want to figure out what the least common denominator of these two expressions is. So, before we can do that, we have to factor each denominator. Now, it doesn't matter what's in the numerator, we factor the denominator, since that's what we're trying to make like. This rational expression on the left is not in standard form, so I'm going to start by putting it in standard form. Right, the highest degree down to the lowest degree. Since that front, or the leading term, has a negative coefficient, I'm going to take out a negative when I pull out the GCF of 2. So negative 2 times, what's left when I divide that out? W, and then positive 6 divided by negative 2 is a negative 3. And then the rational expression here on the right, I'm going to pull out a 3, that is the GCF. Now, the goal is to make these two denominators the same, and that's how we find the least common denominator. So what do they both have in common already? They already have the w minus 3, so that's going to be part of our common denominator. And then what the left one has that the right one doesn't is the negative 2. And the right denominator here has a 3, and the left one doesn't. And now I have everything that I would need for my common denominator. Basically, all I would need to do to add to this one on the left is multiply by 3. What's missing here on the right would be to multiply by negative 2. And the result is the LCD. So I need a negative 2, a 3, and the quantity w minus 3. Or I could simplify this to negative 6 times w minus 3. And that would be the least common denominator for those two rational expressions. Let's dive into this a little bit more. I'm going to go ahead and write this out as 16x squared y cubed and 56x y to the 4th, and then factor them. So 16 is 2 times 2 times 2 times 2. And then we have x squared y cubed. 56 is the same thing as 8 times 7, or 2 times 2 times 2 times 7. Then we have an x and a y to the 4th. The way we identify the least common denominator is we take the most of each denominator, or sorry, each factor. So 2 is a factor. And which one has the most 2's? The one up top. So I'm going to take all of those as part of my LCD. Then I move on to the 7's. Which one has the most 7's? This one down here. So I'm going to take those 7's, or just the one 7. I go on to the next factor, x. Which one has the most x's? X squared is the most. And then which one has the most y's? So I'm going to take y to the 4th. You might ask, why do we take the most if we're looking for the least common denominator? And the answer is it's a multiple, right? It's the least common multiple of the denominators. So for a number to be a multiple of this, I have to at least have 4 2's and x squared. For a number to be multiple of this, I have to have a 7. I have to have y to the 4th. Multiples get bigger, so I have to take at least as much as in each term. So my final answer, the LCD here, would be everything that I circled. So 2 to the 4th times 7 times x squared times y to the 4th. And then if we simplify that a little bit, we'll get 112 x squared y to the 4th. And this will always work. So we can always factor completely, whether it's a monomial or trinomial or binomial or whatever it is we're factoring. We factor it completely, and then take the most of each type of factor. So 2 is a factor, 7, x's, y's, those are all distinct factors. All right, let's look at another example down here. X squared minus 5x plus 4. So we want something that's going to multiply to 4 and add to a negative 5. And I'm thinking, so the only way to get 5 is if we used 1 and 4, and then they have to both be negative to multiply to a positive and add to negative 5. So this will factor into x minus 1, x minus 4. On the right-hand side, we want factors that will multiply to negative 3 and add to a positive 2. So 3 and 1 are the only factors of 3. And if I want to add to a positive 2 but multiply to a negative, I'm going to put that negative with the 1. So 3 times negative 1 gives us negative 3, and positive 3 minus 1 would be positive 2. So this factors into x minus 1 and x plus 3. Now, the least common denominator of those, we see they both have 1 x minus 1, so that's part of our LCD. And then this one has an x minus 4, so we're going to take that as well, and an x plus 3 to complete it. So we have to make sure that the entire quantity from each denominator ends up in the LCD. So this one on the left, I need an x minus 1, x minus 4. I have an x minus 1, x minus 4 in my LCD. The one on the right has an x minus 1, x plus 3. I have an x minus 1 and an x plus 3. I don't need 2 x minus 1s because they both had only 1. So why would I need 2 here? I want the least, the minimum required to be a multiple of both denominators. All right, go ahead and try the ones on the right, and let's see if we can get the same answers. All right, looking at these two on the right, each expression has a monomial. I'm going to go ahead and factor each. So 20a squared b cubed. 20 is the same thing as 4, so 2 times 2, times 5. And then we still have that a squared b cubed. 15 is the same thing as 3 times 5. And then we still have an a and a b to the 4th. Now remember, when we create this least common denominator, we have to take the most of each type of factor. So 2 is a factor, and 20 had the most 2's. 3 is a factor, and 15 had the most 3's. Now they both have 1 5. I only need 1 though, so I only have to circle each distinct factor once. I would not circle both 5s. I only need 1. Which one had the most a's? The a squared is the most, and the most b's would be b to the 4th. Everything I circled is my LCD. So 2 squared times 3 times 5 times a squared times b to the 4th. So 2 squared is 4, and then 3 times 15, or 3 times 5 is 15. So 4 times 15 would be 60. And then I have my a squared b to the 4th. And you can always check this by making sure that both of the denominators divide evenly into that least common denominator. All right, one more here. We need to factor each one of these denominators. The first one here on the left, I want factors that are going to multiply to a positive 8 and add to a positive 6. So 2 and 4 multiply to 8 and add to 6. I'm going to factor that into x plus 2 and x plus 4. This one here on the right, I want factors that multiply to negative 20 and add to negative 1. So 4 and 5 are 1 away from each other. And if I put the negative with the 5, it will add to negative 1. And so those will factor into x plus 4 and x minus 5. Remember, I can only go straight into those factors if the leading coefficient is 1. Alright, so now I can make my LCD, least common denominator. They both have 1 x plus 4, so I only need 1 in my least common denominator. Then I will also have to have an x plus 2 and an x minus 5. And there is my LCD for those two rational expressions. In the next video, we're going to put that together and add rational expressions that do not have like denominators.